And let's evaluate the integral using integration by substitution. So in this case, let's take the e to the power of root x and make it u. If we choose anything else to be the u, things won't work as smoothly. And okay, so once we have chosen the u, we're going to need to take the derivative of this. And we're going to need to use the chain rule to determine the derivative of this. The derivative of e to the anything is just e to the anything. And the inside function in this case is the square root of x. So we're going to need to multiply this by the derivative of the square root of x. And what is that? Well, the square root of x is just x to the half. If I derive this, I'll get half x to the negative half. So I can rewrite it as 1 over 2 root x. Right? Because this x to the power of negative half is just 1 over the square root of x. So this is what I get. And that's, oh yeah, and I need the differential dx here, multiplying the derivative of e to the power of root x, and that's equal to du. Great. Now, what can I do here? In this case, I'm just going to clean this up a little. I'm just going to write it as e to the root x over the square root of x dx. There's a 2 here that I'm going to send over to the other side of the equation. And how can I do that? I can just multiply both sides by 2. So they cancel out, so I get 2 du on that side. Now look at this. This whole thing is exactly what we have here. Look at that. So I can essentially, the 2 is still there, right? So we have 2 times 2 du. Fantastic. So we have just the integral of 4. And I can just take the 4 outside anyways. And we're just left with the 1 inside. And the integral of 1 is just u. Look at how clean that worked out to be. How nice. And now, of course, our u was e to the power of root x, so we just finish with 4e. Of course, we need to replace the u for what we had before, 4e to the power of root x plus the constant. And that's it.